All right, so what you're gonna do is you're going to connect this circuit up. We're gonna have a power supply. You're gonna set it to, what do they want you to set it to? The 12 volts?
12, yeah.
You're gonna set your power supply to 12 volts. You're going to have two resistors. You're gonna have a 2.7K fixed resistor. Then you're gonna have another one. If I draw it like that, what kind of resistor is that? It's not a pot. This is a pot. If I do this,
Variable resistance.
that's a variable resistor or rheostat. Now, the way you're gonna do that, you got two choices. You can change your pot to a rheostat. There's two ways to do it. You can take the wiper and tie it to one of the legs, like that. Or you can do this. You can use one of the legs, then use one of the wipers. Don't use that one. Okay, either way you do it, you can, a lot of people, some people don't like leaving the lead hanging like that. It won't do anything in your circuit, but just depending on the designer, so they like to tie the leg to something. So you can tie a wiper to a leg, or you can just use the wiper and the leg. But some kind of way you got to use a rheostat. And that rheostat's right here. So that's R2. You're only taking two measurements when you're taking three measurements in here. You have a table. I don't know which table it is, but it's a table towards the back where you're going to adjust the value of R2. I think you're going to set it to 0.5K. And then you're going to set it to 1K. You see what table I'm talking about? What page is that on? 65. It's on page 65 at that table. What you're going to do is you're going to start, you're going to adjust this resistor to 0.5 K ohm, right? And then you're going to measure, you're only taking two measurements. Once you set that to 0.5 K, you're going to measure the voltage across each resistor. So you're going to end up with V1, and you end up with V2. Okay, now, this is important. I'll wait till you guys are done, because every time I say this is important, every class somebody screws this up because you're not listening. When you adjust this to different values, 0.5, 1K, whatever it is, you cannot make this adjustment with this connected up to the circuit. I did this lab last week. I said the exact same thing to people in the class, and guess what? Two people did. They adjusted this, connected up to power, and all their data was incorrect. It's like they didn't do the lab. What you got to do, every time you adjust R2, you have to disconnect one of your power leads, adjust R2, and then reconnect it. If you try to adjust R2 with it connected to power, you're not only measuring the resistance of R2 and R1, you're measuring the resistance of everything inside the power supply, which is not what you want. And your data will be incorrect. Okay, so make sure every time you make an adjustment for R2, disconnect one of your power leads, adjust R2, put it back, and then get your voltage measurements. Once you see how this is going, then this lab just takes a few minutes, literally, maybe 30 at the most, and it's on a slow day. Now, what does this remind you of? Let me draw it a different way. If I draw this circuit this way, what does that remind you of? All I did was move this resistor to the top. What does that remind you of? Thevenin. Doesn't that look like a Thevenin circuit? A Thevenin circuit, in a Thevenin circuit, you have a voltage source, it's called VTH, we call this VS. This is almost like a RTH and a VTH, isn't it? It's just like a Thevenin circuit. And if this was a Thevenin circuit, as you adjust this resistor right here, you're going to start off at 0.5K, and then you're going to increase it in increments of what, 0.5K or something like that? What are you graphing? What's the point of this lab? What are you graphing? Power. What would you expect the power curve to look like?
No, decrease. Sorry.
Increase, decrease. What is it going to look like? It's going. What do you mean when you say increase? Tell me what's going to happen.
Well, when you're adding more resistance, you're going to come out with less.
Less power. Is that right?
Yeah.
What do you think, Riley? As I increase this resistor right here, what should happen to the power?
Oh, okay. It was.
What's going to happen when this resistor and this resistor are equal to each other? If this was a Thevenin circuit and these two resistors are equal, what will happen? Don't tell me I wasted that whole video on Newton's cradle for nothing. Huh?
Max power.
Max power, right? You would expect the power to start off at a low value.
It's going to go up and then go back down.
Say it again.
It's going to go up and then go back down.
That's what you expect. Do you see why?
It's going to go up to the max power and then go down after the max.
It has to, right? Because only when RL and RTH are equal, if this was a Thevenin circuit, it's just like one, would you expect to get max power? So what you should see is exactly what he said. You should see the power go up, and then it should go back down. When will it peak? It should peak when that resistor is very close to what? That one. So you're going to measure the value of this, and when your potentiometer, your rheostat value is close to that, that's why I'm going to just look at your numbers. So I want to see your numbers before I sign off. I'm looking for this peak. You don't even have to make the graph. Just fill out the table, and we can see if it's going to peak. Question?
So let's just say we make the mistake that you warned us about. Will speed be wrong?
Yes.
Like, will that be
People
like
be
a
wrong. People be wrong. So I'm going to look, and usually I don't even tell students about, because I want them to make the connection themselves about maximum power. I don't know if they ever do. You guys know Bloomfield, Professor Bloomfield? I sat in and want to hit, and you need to take his instrumentation class and PLC class. He's the best. Yeah, he's the best. But what I like about Bloomfield is what he does. He doesn't do like me. I just give the lab, and you got to figure it out. He'll give the lab, but then after the lab, you kind of huddle up, and then you talk about what the results should have been to make sure everybody's crystal clear on it. So I'm trying to get better at it like him. I want you to know what you expect to see. I like you to kind of discover things yourself, but sometimes students don't think and make the connection.
What does he teach?
He teaches process instrumentation and then PLCs.
What's your major?
BMT.
Biomedical?
Yeah.
Yeah, and I think I mentioned this. I don't want to get off on a tangent, but if you guys are early in your degree program, I highly, highly, highly recommend taking a second major. And I don't get any extra money from Cincinnati State by saying that. It's just that Cincinnati State is one of the few schools. I had a double major when I was in college, physics and philosophy, but I can only get one degree. This is one of the few schools, if you get a double major, you get 2 degrees. And if you're early enough in your program, you can take an elective in one degree program might count as a required course in another. If you play your cards right, you can take maybe 3, at most 4 of the courses, you got 2 degrees. That makes you a lot more marketable if it's in the right thing. The problem is if you're electromechanical, there's certain classes that you should take that you won't. I don't think you take Dig 2. That's a sin. That's blasphemy. You got to take Dig 2. I don't even know if you take Dig 1. So they had to do that because years ago, the state of Ohio required all community colleges or state colleges to cut the credit hours back. So we had to take courses out. So I've been pushing students to try to get the double major, and I have a couple that did. I don't know anybody that was upset that they got the double major. Everybody was very happy that they did that. So if that's something you're interested in, talk to me later on, that I can point you in the right direction. Here's everything you need. There is a diagram. Didn't I give you guys a diagram of that board?
Yeah.
That's it. Yeah. Where's that? Did I have that diagram? Cause I want to show you something.
Yeah.
Yeah, you see this? Okay. Oh, wait a minute, is this the one? Oh, this was off the rock. Okay, all right.
Yeah.
All right, no, that's cool, yeah. If you have any trouble hooking this up, let me know. I guess I can stop the recording now. Or should I let it go? I don't think you guys will.